Part 5. Right. IoT Fundamentals Part 5. So this is the last part of the IoT Fundamentals. After this, so for tomorrow we'll start getting into some crypto revision, or your next, whenever the next, I think it's tomorrow, yeah. So this is the last bit of the IoT Fundamentals. And as I said, this, I actually find this one one of the more interesting ones, the problems and challenges, which we already have discussed some of them. Standards, so in other words, if you don't base on standards, you have a problem, or if you have a lot of stuff already out there, that can be an issue. Lots of different stuff, but we'll get there. Power is a big issue. If you don't have mains power, you're down to batteries. And are they rechargeable batteries? Are they non-rechargeable batteries? Are they costly batteries, cheap batteries? So that is a challenge for IoT stuff, but we talked about that ad nauseum. Some other ones. Some security issues, hence the name of the course, some legacy systems. As I said, that ties in with standards, in that there may be a lot of stuff out there already that people have put out there for the last few years, and can you update it? That ties into the next one. Legacy systems, all different types of systems, maybe not generic, Linux-based OSs, into the heterogeneous issue is again. Let's say remote updates, big issue. How do you change stuff if it has a bug, let alone a normal bug, could be a security bug. Data volumes is an issue, and there's a lot of data out there. These sensors and IoT devices and just devices in general send a lot of data centrally. Where's it going? Where is it being stored? Who's paying for it? And security as well. And then fault tolerance of unattended devices. Whether you like it or not, most IoT devices are unattended, which means there's nobody there to press restart or reboot them if there's an issue. So you have to build that in if you're designing unattended devices to make sure that they can recover. So again, these are things, if you ever are getting into this area, designing products for this area, you need to be aware of these issues because they are going to cause problems and they are challenges you have to overcome. So the power problem, as I say, we already briefly discussed, or more than briefly. Many sensors, non-rechargeable, need to last for years, typically 5 to 10 years, be very cheap. They're not usually designed so that the batteries can be replaced in them. They're usually designed to be thrown away and a new one put in, because if you design something that the battery is replaceable in, that costs you more money in the first place due to the plastics and how you mount the battery. So technically, typically, they are not replaceable and they're very cheap and they're hoofed away after X years. All right. So we need suitable embedded systems. You apply for suitable or blah blah blah. So we need, because these things are cheap and have low power, we typically can't use things like 4G, 3G, 5G, whatever, and we have to use the other LP1 based designs, okay, and that in turn causes some other issues, but we'll talk about that later. Standards. So what does it say here? In order for the market to really take off, several key technology hurdles to be addressed. So you need, let's say, if you want your thing to scale, as we said, you need ubiquitous, which means everywhere. All right. Standards for communications, as I say, you can't base on a non-standard. And let's say new software architecture. We need those two things to happen, right? We need architectures that support massively peer-to-peer complex. So typically like Android or Linux or any sort of typical software architecture. If that is not in place, you will not be able to scale, all right? You will not be able to, your market to be take off and make money, or it just won't happen, right? You need those two things. Unfortunately, historically and up until recently, there's still a lot of stuff out there that is not fully interoperable, right? And so you've got a lot of legacy type systems out there, which people, because they wanted them to be cheap, to design them people started using more and more standard stuff like Android or Linux based or Pi based or whatever, or even this LoRa stuff and this Sigfox stuff. Before that, people mishmash of all sorts of stuff out there, and they're not fully interoperable, right? So how do you deal with that, right? So you have a mix of stuff that's out there. You've old stuff and you've new technologies. And what we're going to come to is nearly like, remember the way phones used to be, right? You had all these different type phones, you know, from Samsung, from Apple, from God knows where, all these different, and were they all Android? No. Yeah, were they all iPhone? No. There was all sorts of candy bar jobs. Now I know some of the candy bar jobs have made a bit of a resurrection from Nokia and things like that. But what actually happened there is they've taken standard designs and put them into those because they still want to take advantage of 4G stuff. So you can buy little Nokia things that look like the old ones, but they're using 4G. Okay, so they're not really legacy stuff. But anyway, there's a mix of all different types of stuff out there. You've IPv4 stuff, you've IPv6 stuff, whole different mix of stuff, right? And what I'm trying to get at here is if you can draw the analogy at the way the phone market went, right? There was all these different types of phones, and we all know now that we're down essentially to two, right? There's Apple types or there's Android types. Nearly everybody in the world has one of these two, unless you're deliberately trying to have a really cheap phone that just does, or you're, God forbid, a drug dealer or whatever, and you literally have, you know, the simple throwaway phone that's only used for phone calls and text messages, right? Or in certain parts of the world, those phones are still being used because they're really cheap, or you're a builder and you need something that bounces, right? So you don't want to smash your nice Android. But realistically, we're down to those two. And as I say, true scale IoT will be similar sort of thing, all right? So in other words, at the moment, you've got all these different types of IoT devices out there. You've got all these different type IoT host systems out there, which is more important, right? And we'll talk about that in a minute. Eventually, it will come down to 1, 2, 3, more than one, obviously. Hopefully, otherwise it's a competition issue. But I'd say it'll come down to most likely 2 or 3 being the lead in all the cloud stuff and the host stuff on the IoT stuff. You'll still get a certain amount of variation in the sensor end of things, but true scale it'll boil down to be something. And I'll show you a table before we finish here today. And it's the typical setup of all the different, or some of the players in the market for the host end or the cloud end. Okay. So it will come down to these things. Emerging technologies always work this way. You have lots of different early adopters. So you have lots of different companies go out and they try to create the standards, and they try to create the one that everybody else wants to follow, just like the phones. Same thing has happened with IoT, and so you've got different ones from. Well, we'll see it anyway, and you'll see what I'm talking about. Okay. Another example just of scale and standardization, right? So you've all at this stage you tap, everybody tapping with their cards. Well, that has reached scale. It has reached standardization, and now everybody just takes that for granted, right? But it really only took off in recent years, the last few years. But I can tell you that I was working on that stuff 10, 15 years ago, right? And people were saying, it's going to take off, it's going to take off, it's going to take off. And the companies, like the company I used to work for, like Verifone or Genico or I, we spent millions upon millions upon millions on tap technology. It's called contactless, and putting that in all the products. And the problem was that Visa, MasterCard, Amex, they all had so many different versions for years and years and years, because they were still learning. They were still trying to get the technology right so people could adopt it. And in order for it to take off eventually, they came down to similar standards between the three of them, all right? Because otherwise it's changing every 6 months or whatever. So a standard infrastructure, it has to be secure, obviously, and the complexity of it was conquered to a degree, and the cost had to be right. But what I'm trying to say to you is that was an incredible example of something that all these companies were pushing out the door, trying to get people to adopt their version. And until it achieved standardization, you couldn't scale it. And then the minute it did, and people started to adopt it, then you saw the scale. And as I say, it's incredible now. Everybody just takes for granted. What would the world be like? What would the COVID world have been like if you couldn't tap? imagine that? So it is just totally taken off, but it's a nice example. Where did we hear those 4 things? Well, it's just exactly what I said in the previous slide, right? Which was this. Yeah. So it's a nice example of that. And the same thing will happen with IoT stuff, right? We'll go from this myriad of IoT stuff to some few standard ones that most people adopt, be it ones from God knows who it'll be from. I'm not sure who it'll be from, but it'll be, you know, in 5-10 years time, we'll be talking about all this stuff, and it's all from company X or company Y. Okay, so let's have a little peek. One of the challenges, the other challenges we said was security, and security obviously these days is a huge issue. And if you get it wrong, bad things can happen. And if you get it wrong with millions upon billions of stuff connected to a network, and they're all the same, it tends to get really bad. But some early examples of problems that occurred with, let's call it, unattended IoT type devices, right? We have this evolution, right, of products embracing IoT. Let's just think about it for a minute, right? It's a medical device, right? So this is how we went from, you know, simple devices to complicated devices. And as you're going through this, think about security as well. So medical devices, yeah, everybody knows, has heard of pacemakers, insulin pumps, heart monitors, right? They started off as a standalone product, right, that did something. Then they evolved into something that became more smart. Metrics, data, always, that's what people are looking for, right? And then, so in other words, these things used to be able to gather metrics and gather data, but how did you get the actual data off them? Well, it used to be you had to plug something into them, but now they're connected. They can connect automatically. So same idea, right, as we've seen with IoT stuff. Once you have a device that has a unique ID and you can connect it, you can then scale it and good things can happen. So a medical device is an interesting example as well. A car is an even more interesting example, right? If you look at how cars have evolved over the last 10, 20 years, used to be just was the car, you know, and you didn't have much smarts in it at all. Then it became that, you know, certain things were stored and available to the driver. The next thing was you could plug in, and I don't know whether you've ever done this, right? How much you know about cars, but you can. It's like a SCART adapter nearly. You can plug something in under your dashboard, and if you've the right computer, you can get access to certain stats on the car. And the mechanics obviously plug into it and find out exactly all the codes that have happened that were stored over time on your car, because the car they all have an electronic brain at this stage, right? So that was snazzy enough, but really they've changed big time in the last 5 to 10 years. Whereas now they all have on-loads. Tesla is the high-end example, but just any normal car now has, you know, an audio, an infotainment system, they call them, right? They all started off being embedded Linux about 10 years ago. They've morphed now into Android systems as well. So like, and they are talking back to mama all the time, getting updates all the time. I won't get into how, well I will actually, how you wouldn't believe the standards that happen in a car to make sure that the infotainment system can't interfere, or something can be downloaded that can interfere with the actual car management system. They're two separate systems in a car. The car management system is heavily regulated, right, and heavily tested, whereas the infotainment system, it's a wing and a prayer as to whether that thing works properly. That's getting updates all the time. The GPS system's getting updated all the time. But the car management system usually is running on a total separate CPU and processor. Although, I will tell you that I worked with a company, well, someone was trying to sell, they were trying to sell us their stuff, but it was essentially virtual machines. The same processor had two virtual machines, one for the car management system and one for the infotainment system. And the amount of certification that had to go through to prove that you could update the infotainment system without messing with the car management system was enormous, right? And that's where security comes in. But anyway, just an example. What I'm trying to make here is cars and how how they've evolved to become extremely complicated and extremely dangerous. Because if you look at about it, that report there is an interesting report. By 2020, 90% of cars online compared to 2% 8 years previously. Like, that's incredible growth, right? And that's scale for you, because all these things are connected, but they all have issues, security issues. And then the home is another example. Home started out, you only have manual control to control certain electronics or aircon. Over time, everything was connected to the internet, so everybody could avail of broadband. And that in turn has led to, well, actually, why don't we connect the systems that control the house to the internet, and why don't we then control them centrally or report them centrally, whether it's alarm systems or video cameras or emergency service access, all that type of stuff, right? And a fella in fourth year in part-time did a really interesting project a couple of years ago on this, and it was all connecting. He had a neighbour, believe it or not, who had a Samsung-based smart home, and your man, the neighbour, let the fourth year student access to his system for his fourth year project. Like, I don't know whether I'd be allowing some fourth year project access to my smart home system if I had, but the guy was able to do a project on access to it, turning on and off stuff, securing it, built a dashboard to show stuff. It was really, really good. And not that difficult because everything is connected via standards. Right? If you tried to do that 15 years ago, you couldn't do it unless you had the specific system that came from whatever, Samsung or whatever. Okay, so again, evolution. But as I said, the intro, why did I talk about evolution? Because it in turn creates a lot of security problems, right? And the main issue is all this stuff is using, plumbing that was security was not always being the most important thing. All right. For an example, and a prime example is IPv4. There is no security in IPv4. Okay, so that in turn creates issues. IoT products sold with old, unpatched embedded operating systems and application software. Like, people just, because they were chasing the market, would produce these things and lash them out there. Look at the next point. Default passwords on routers. One of the most famous ways to create botnets that exists. Or if you do change them, they don't change them to significantly strong passwords. The suppliers of these things don't even enforce you changing the password setting. Why don't they do that? Well, they don't do that for a very good reason. Why do you reckon router suppliers, aren't big on letting everybody change their own passwords to be whatever they want? Why do you reckon? Why does it suit them to have them all being that it's admin to get into a router? Anybody want to guess? Easier to ship is one. No, that's okay. Ease of access for support, right? So in other words, when your router starts doing something silly and you ring them up, they can remotely access your router to find out what the problem is. If you've changed the password and you can't remember it, guess what? They can't get in, all right? So all simple, practical things like that. That's one of the reasons why they don't really like people messing with the router. But they couldn't be arsed trying to make them secure enough in the first place. So they're essentially giving you a computer, which is your router, which is accessible from outside, but anybody with a brain can access it from outside and use your router as a computer, because those routers are all essentially Linux systems. Okay, so really, really dangerous. I'll give you another few. Issues, right? Networking itself is an issue, right? So an IoT device that needs to be directly accessible over the internet should be segmented its own network and have network. So what does that mean? Well, hopefully we'll do it in a lab in a few weeks' time. But essentially what I mean is, if you have a lot of IoT devices in your house, you should have them on a separate subnet behind your router, not on the same subnet, right? Because you might have different permissions on that subnet to allow people to log in to the IoT or not log in to the IoT device, okay? But do you think that is typically done? The answer is no. People buy IoT devices and they just show them on behind their router and allow access into them, okay? So really, really dangerous stuff, okay? This isn't new stuff. The lads, security experts, and there's a couple of examples here, have been warning about this for years, all right? That if you have all these things and they are, using modern designs, which are essentially Linux-based systems or some standard OS, and they're all connected, then you have a serious issue if they're unsecured. And back as far as 8 years ago, 2013, because your man at ProofNet, he basically claimed that 25%, so he discovered the first IoT botnet, and 25% was, look at what it was, smart TVs, baby monitors, and other household appliances. And that was 8 years ago. Can you imagine what it is now? Like, who nearly doesn't have a smart TV at this stage? Built-in Netflix and blah, blah, blah. If the thing has built-in Netflix, guess what? It's talking out to a Netflix server. And it's been updated all the time. So it's got connectivity to outside. Who's responsible for the security? You're trusting that the TV supplier is being responsible for its own security. And so it's just rife. You have to be really careful. Anyway, so the result of all this, is that what's this sentence actually mean? Any vertical market product will take advantage of interconnected systems of systems. Whoa, what a mouthful. What does that actually mean, right? What it means is you can sell a product in a certain market, a vertical, right? Like a TV or like a router. That's a vertical market. Routers. I'm going to sell routers, or I'm going to sell TVs. But unfortunately, because they're all standards, the router is using an IPv4 stack to talk out to the internet. The TV is sitting behind your router using IPv4 stack probably to talk out via the router to the internet, right? If I have a piece of software that's rogue on the TV or any smart IoT sensor on the same subnet, guess what? The chances are it's in behind your router at that stage, in behind your firewall, and God knows what it can do to the devices that's on in your house. Okay, so you have to be really, really careful. But what that sentence means is something in a certain vertical can jump across to any interconnected device on the system. Right? Very, very dangerous. And unfortunately, these systems are going to continue to scale, which gives us lots of security challenges. Right? Data, how it's stored, how it's processed, how it's transmitted. So, okay, this is all about security. Remember our word vulnerabilities from second year? What does it mean now if we think about it in terms of IoT devices? Well, this guy is famous, this Bruce Schneider guy. Again, this is 7 years old, his quote, right? Very topical for the way IoT has grown. He said 7 years ago, the security of embedded systems, which is essentially what's in IoT devices, where computing is embedded into the hardware itself, as distinct from a standard user-based device like a phone or a PC, like the Internet of Things. These embedded computers are riddled with vulnerabilities, and there's no good way to patch them. Remember I showed you all the vulnerability databases in second year, and every piece of open source software out there, or not even open source software, everything has got vulnerabilities, and they're documented, and they happen all the time, every day, new ones, and you're supposed to patch them if there's a serious problem. Well, how do you patch a load of IoT devices that have no way to be patched? That's what your man was trying to say. Now, and if there's, how many did we say there was? 16 billion at the moment, 14 billion? And that's a lot. That's a lot of potential problems. And this whole sort of idea is not new, all right? This idea whereby I have a lot of stuff connected, and it has a lot of shit software, a lot of insecurities, and how do I update it? It's much the same as what happened about 25 years ago, right? So we had all these Microsoft computers mainly Microsoft, software now riddled with security vulnerabilities, and there was no good way to patch them. In the mid-90s, why was there no good way to patch Microsoft Windows 95, 3.1, 98? Why was there no good way to patch those? Any ideas? You take it for granted now that your computer or your phone or your iPad or whatever updates. Yeah, you couldn't. Why couldn't you distribute it, Sean? Yeah, exactly. In the 90s, we didn't have broadband, right? Yeah. We didn't have the speed we have now. We had dial up, or if you were early broadband, you had some God knows what sort of bandwidth of a connection, right? And it just didn't exist. So you were getting updates, if you were lucky via floppy or something, right? Or you never updated your operating system. So like imagine if you tried to do that now. Imagine if you said, I'm going to give you a phone, right? And here it goes, does X, Y, Z. It's brilliant. Well, by the way, it can never be updated. Do you think you'd buy it? Not a chance, right? Not in the current climate. But that's essentially what was going on back then. So there was no good way to patch these. Why? Well, one of the other reasons is because there was no way to patch them, the companies themselves, like Microsoft or whatever, they keep them secret and they wouldn't release security updates. And even if they did, how do you get them to install them, right? So it was just totally different times. So as I said, we've been here before. Yeah. So it's changed. Full disclosure, but it's changed. Well, it doesn't matter now if you don't publish those issues with your software, somebody else will, and you have to change it. And then the beauty is at the moment you have all this ability for automatic updates, right? So that's cool. That actually has solved a big problem we had 25 years ago, right? It's great. So hopefully for IoT, sure, we're laughing, aren't we? But not really. What solved the PC crisis is actually helping to create the IoT security crisis. What do I mean by that? So we've got ubiquitous fast-speed internet access. Sounds like a great thing, right? Which basically means everywhere we have stuff fast speed and it's connected. It solved the PC problem that took away user action. Updates are applied automatically. Why won't that work for IoT sensors? It won't work for IoT sensors because what we are now is there's PCs, right? They're all main. Back then we had one, now we have three. So Windows, Linux, or Android, and Mac. So it's easy to design a reliable update for those three over a stable, fast broadband, right? That's why everything's cool at the moment with your phones, with your Macs, with your Windows. Well, it's not cool, but it's a lot better than it was, right? But can you think about what I'm going to say next? Why this ubiquitous fast speed has actually has created a problem that solved one problem for standard phones and PCs, but it actually has created the IoT because there are so many devices now that people have lashed out there. They're not all Apple, they're not all Mac, they're not all Windows, they're not all Android. Some of them are, a good few of them are, but all these little sensors now, they're not, okay? They're all using different protocols in different ways, and it's easy to design something and put it out there. But is it easy to update it? Can you build the one system that will cover a load of these sensors? No. And that's what I was trying to say to you was, over time, we will go from, you buy a sensor from company X, it's using God knows what design, company Y, different design. Over time, that will be like the phones. And over time, everything in IoT land will come down to two or three big players in the market will cover the whole thing, right? Because that's how you scale. So the Internet of Things at the moment is lots of different possibilities, lots of different ways of making a killing and lots of money, but it's fraught with danger as well, okay? Over time, it will become a standard. So the mismatch, what you're saying, the mishmash of industries producing are even less capable of fixing the problem than the So most of these guys, they're not capable of fixing the problems they're causing, and do they even care? All they want to do is make money, all right? So the point I'm trying to make here is the high-speed broadband, everything connected, solved one problem, has created this great opportunity in IoT land, but has also created problems, security problems, update problems, lots of problems. And so it's a wonderful opportunity to make money, but it's also a wonderful opportunity to cause problems. So, key question, will IoT be secure? Each connected device represents a potential point of weakness, allowing unauthorized access. What's that mean? Security requirements, any connect must be addressed. We need to have, what are we trying to achieve if we are trying to make a device secure? We need to have confidential data comms between devices. Okay, fair enough. So basically what we're saying is, if I have an IoT device and it's talking to Mama or central cloud server, I want to make sure that if the data needs to be confidential, I have some way of making it confidential. That sounds like I have some way of encrypting it. Remote device access and device identity management. In other words, I might need to get access to this device remotely. I might have to log into it, and I would like to be damn sure the device is the device I think I'm talking to. It is the one I'm talking to. Similarly, authentication of devices and device application on the network. So in other words, if a device comes on the network, it's authenticated, it should be there. And similarly, any applications that are on that device are the real applications, they're not role applications. Have we covered those three requirements in security before? What are they? Do you remember when I first started teaching in second year and I said, if you're ever answering any question on security, make sure you talk about a particular thing. What was it? You remember? Yeah, exactly. Confidentiality, integrity, authentication, access. That's exactly what those three things are. Okay? So anytime you're having a security conversation, you bring these three in as the exact same thing with IoT devices. We need to make sure that we can be confidential when we need to. Stuff doesn't change if it's not supposed to change, and we can get access to stuff when we need to get access to it. All right? So when it goes wrong, you can have serious problems, right? We'll have a look at a couple of examples here in a second. And it says, as long as IoT connections and data increases, security isn't increasing. Well, I think you know this because every week that goes by, you hear a different disaster in terms of security. And it's become very, very topical in the last few years with ransomware and all the stuff. And a huge source of ransomware into your system is people connecting things that aren't secure, or the people thought they were meant to be safe to be on the network and they're not. So some interesting early examples of when it goes wrong. So early IoT sensors or tags were these RFID. You take it for granted these days in shops. There's, you buy clothes and they all have these RFID tags. But when the US first started introducing US passports with these electronic tags in them, the data could be read as far away as that's 10 yards with equipment available for 250 meters. So in other words, you could walk by people's passports 10 yards away and you could scan all the information off the passport. Very, very dodgy. All right. Similar things are done robbing cars at the moment, whereby people have cards on them that automatically unlock the car when you're a certain proximity to the car. There's ways around trying to hack those as well. Similar idea. This was a good one. Our friends in Jeep had a bug in their vehicles. So as we said, cars are a good example of how IoT stuff has evolved over the years. Well, the lads had a bug. No big deal. Every piece of software has a bug. Well, this particular one, unfortunately, allowed people to remote hack the car and allow remote control of the car. So as you can see, you can have serious issues there. And what two cybersecurity guys did, they found it and they made it public. So I think you'll find that they contacted Jeep first and said, if you don't fix this, we're going to make it public. And eventually they made it public, and that meant Jeep had to recall all those cars. All right. And again, I'll bring you back to that report. You'd have a quick read of that. It's a few years old at this stage, but essentially what it's saying is it's quite a scary thing in terms of scale. Like 2% to 90% in 8 years. That's pretty impressive, right? Just this one, like I highlight this one to people, but we're all guilty of this, all right? And this just is a good example of how hard it can be to not fall for the problem, because, you know, unfortunately, remember the SUF triangle where we talked about security, usability, and functionality. If you want to be really, really secure, you create a nightmare for yourself, right? In terms of, you know, just access to stuff. So here's an interesting one, right? So how many of you at this stage have so many different accounts on so many different systems out there, right? So if you take as an example, if you had a load of IoT devices and you wanted remote access into them as well, what do people typically use as their username? What are you typically prompted for all these remote? No, you're not. Think about it. Anything you sign up for on the internet, what are you typically asked for, or it suggests, or you don't have a choice as being your username? And I'll give you a clue. It's because it's unique. Exactly. Your email address, right? How many of you have signed up to all these systems with your email address and use different passwords for all those systems? Or do you use the same password typically? Or maybe you might have one or two. Most of us use the same one, don't we? Why? Because how are you going to remember it otherwise? Yeah. So imagine if someone hacked that. Someone who's trying to pretend to be you. Well, the odds are high. It's probably easy to find out your email address. But if they got your password to one of those systems, they can get in to all the systems that you have. Okay. So that's why, you know, and if you extrapolate that to IoT systems, the odds are high. If I told you, you know, you had all these IoT systems and you could remotely log into them, and it was email address and password, how would you get into it? You'd probably use the same thing. That's why SSH is important. Remember we did SSH, and we may revisit it quickly in the labs if we have time, just to make sure everybody gets it. The importance of SSH rather than usernames and passwords, all right? So anyway, that's all I was trying to highlight. Your email address, blah, blah, blah. If you get a data breach, you're screwed because people can get into them all. And sadly, you know, the fact that we have all these IoT devices with this lack of security, there's loads of factors why it happens, right? But this is the obvious one, which is people develop stuff and ship it out to the market as soon as possible with little regard for security, right? Remember we covered this in second year? In other words, just ship it out there, make money, blah, blah, blah. We'll fix any issue that crops up later. Unfortunately, with IoT devices, it ain't so easy to update them. Okay, so what this is basically saying, it's a low priority typically when you're shipping out new products, right? A lot of people don't genuinely realize this is a potential problem. Like a lot of people don't deliberately go out to say, I'll put this out here and I don't care about security. They don't realize that it could be a problem. But if you're building products based on standards, OSs, connectivity, you are creating a problem if you don't take security seriously, right? And as I say, due to the lack of, anybody know what that word is without looking at the next slide? Due to the lack of something, this error is not always deliberate. Mostly isn't. The word is regulation, right? So in other words, if there is no regulation or certification or punishment, well, you don't envisage consequences. So what this is trying to say is it's imperative that security becomes built in, easy, cheap to use. Easy, cheap to use means it's not creating a massive headache to use it. So the message to you is if you ever get into this area, make sure you think about security. Obviously, you don't need to go to the nth degree if it's, you know, some silly sensor that doesn't matter if someone hacks. But if it's something important that someone could hack and cause a problem, then you need to really, really think about security. All right. So if we combine cloud, IoT, security, if we combine all them together, right? as we said, we have the core requirements are our CIA, right? Fair enough. But look here, at the other end, at the cloud end, there's lots of different frameworks or how I could connect my sensors to Mama centrally, right? And there's an article there, you should have a peep at it, right? It's many different frameworks from Amazon, Microsoft, Google, they all have it, right? Now, if I had to bet where we're going to be in 10 years' time, I would say, you know, I could take a bet that the top three there, the first three, will have a pretty big say in this, okay? But that's just me, and the others will fall off. You know, Ericsson will fall off, Samsung may fall off, whatever. Apple will probably be there somewhere as well. But it will come down to standards. There's out of that article, right? There's a table, and I don't need you to know the table. I pointed out two rows in particular, just to prove to you that I wasn't talking rubbish, right? So if you look here, the supported application protocols. So we'll see things like MQTT, MQTT co-op, MQTT, MQTT. So MQTT co-op, you will see, makes an appearance in all these, and for good reason, right? Because as we know, they're the ones for not low bandwidth, right? We want to be able to move easy stuff. MQTT, not a lot of data. Co-op is great. MQTT, publisher subscriber, really good. Lightweight clients, all that type of jazz. And the other one I wanted to show you was communications. So we'll see our old friend SSL, but we also see DTLS start to make an appearance as well. All right, so just to prove that it is out there. Just a few other ones we said we discuss. Remember, this is chat problems and challenges, remote updates. So at this stage, we've said a lot of stuff gets shipped out there. There'll be bugs, there'll be security issues, therefore you're going to need software updates. But they're very cheap devices. Will they even support remote updating? Let's face it, remember what I said? These things are typically throwaway devices. So are you really going to have double the memory in there so that you can update them? Sometimes not. So if they're not, and you have a bad bug, you could end up with a problem. You could end up with a recall. You'll end up with no one will buy your products ever again. So you have to be really careful. If you have to update it, will it be reliable? Or will it produce what's called a software break after update? So in other words, if you try update and something goes wrong, does the thing reboot? Does it start? I've seen that, right? Famous ones, set-top boxes failing to work properly after updates, all different type of stuff. So remote updates is really, really important. And again, it depends on your market. If you have a very cheap thing and it doesn't matter, if it has a few little bugs, right, as long as it does roughly what it's supposed to do, fine. But if it has to be updated, if there's a chance it has to be updated, you better make damn sure it's reliable, that it can be updated, has enough memory to be updated, right? So be very, very careful with that. Also, sadly, if you do need to remote update these, unfortunately, the sensor is the least of your problems. The real problem is you need a management system centrally to be able to update them. Why? Because if you have thousands and thousands and thousands of these things out there, let's face it, you've been successful, you've made a lot of money, but now you need to update them. How do you do it? You could have products that have been out there for 1 year, 2 years, 5 years. They'll all be different versions. How do you update them? Do you update them all at once? Why wouldn't you update them all at once? Or do you update them in groups? Why wouldn't you update them all at once? I have 10,000, I have 100,000 devices out there. They all need an update. I'll do it all at 4 o'clock in the morning. Why mightn't I do that? That's one. What's the obvious one? No, maybe it's only 5 minutes, maybe. No, what's the other big one? You're thinking about it all from the device end. You're thinking, what about the other end? No. Okay, if I have 1 million devices out there, what's the issue at the central end? If I want to update them all at the same time, what's the issue? Bandwidth, exactly, Rory, well done. Okay, it's bandwidth. How do you do them all at the same time? You've got to have a socket connection open for every single one, right? So typically they'd be done in groups. But as I say, the management system behind this is very, very, very complicated. So typically, it's okay to update all at once if you have a small number. But imagine, as I say, the server and the comms load, if you try hundreds of thousands or millions, right? And if you've been successful, that's where you will be. The next issue is, okay, I've something that has, it's got an issue. I've got to update it. Do I update all the software, the OS on it, or do I just patch? Why is it important? Why is that important? Why is that important? Well, it's mainly bandwidth again, okay? So in other words, a big difference, or maybe it's using a protocol that doesn't allow me to download, thousands of bytes per second. Maybe I'm using one of those LP WAN ones that we'll talk about, Sigfox or LoRa, and I've only very slow communication speed with these sensors. I can't upload the whole thing. I can't update the whole thing. I might have to patch it, right? In other words, I just download the bit that needs to be changed. That makes it very complicated, by the way. All right. So I'll just give you an example of all the different issues that can be. And that's the reason why, okay, there may be difference between a full update and just a patch. And then there's this one, fault tolerance. Most of these IoT devices are unattended. Does everybody understand what unattended is at this stage? What's unattended mean? Everybody know what unattended means? Somebody have a guess? They're out on their own, but unattended typically means there's nobody there to reboot them if there's an issue, right? So in other words, when you go to a shop and you pay for something, the credit card machine, there's someone there, and if it doesn't work, they reboot it or whatever. Yeah. If you go to a vending machine and you try pay and it doesn't work, there's no one there. So a vending machine is an example of an unattended device, right? So most IoT devices are sensors are unattended, which means no users present, which means big trouble if you have a hang. So an IoT device has to be fault tolerant. So I've told you this before. If you ever write software or deal with something that is unattended, make damn sure there's something in the background monitoring that the thing is still running. And if it isn't, then you apply the sledgehammer method and you reboot it, right? Believe me, you will be thanked more for that than the fact that where did the thing disappear to for a minute while it rebooted? At least it kept going, right? And the odds are lots of your faults or bugs will never come to light because in the background it's doing this and it's restarting. All right. So, however, the last line is really important. If you're a good little person, a good little boy or girl writing the software, you should make sure that you should report issues to some sort of central management system that the thing is probably connected to say, I had an issue, here's as much a debug log or whatever I can give you of whatever it knows. So in other words, it knows that it had an issue, it rebooted and there was an error code or whatever. So somebody might be able to figure it out. And then in the next time they are updated or the next batch or shipped with new software, it'll be fixed. All right. So that's essentially what you should do. Always have a background monitor, but always report as much information as you can back centrally so that, in other words, data, metrics to help the product evolve. And then I'll leave you with this, which to me is very scary, all right, which is that is data volume, storage, centrally, dating from in the last 10 years, projected out to 2025, okay? This one dates from a couple of years ago. Doesn't matter, I can pull another one, you'll get the exact same thing. But the blue is typically the non-IoT stuff, right? This color is the IoT stuff. And as you can see, it's gone from 10 years ago, very little, to projected, that's only 4 years away. Look where we are now. I didn't look to see what it actually is, but it's basically saying, the blue one's probably 2, and let's take this snapshot as about 10. That's 10 zettabytes. For those of you who aren't sure what this is, Megabyte is 10 to the 6. Giga is 10 to the 9. Pico is 10 to the 12. Zeta is a bloody big number, right? And that, if you think about it, that's the amount of data that's typically being sent up to mama bears centrally in IoT. It all has to be stored somewhere. It has to be secured typically. That's a lot of data if someone hacks in and they can get it. And again, if you have a read of that, you'll find out what I'm talking about. So that's a problem. That's a challenge. And then we'll cover how you hopefully deal with it centrally. And so I'm trying to concentrate on the other end of it. But it's a big issue. All right. So if you go back, as I say, I personally think this deck is one of the more interesting ones, right? Because there's a lot of real world stuff in there. But what did we talk about? So there's quite a few problems and challenges. The standards, the power, security, legacy are all up to them and fault. Okay? So there's lots of things there you could talk about. So you need to, look, it's fourth year, right? When I ask you a question or someone asks you a question in an exam or CA or whatever, yeah, it's not going to be can you regurgitate the slides. It's can you, in your own words, describe typical problems. If I ask you something, typical challenges, how you might overcome them, blah, blah, blah. Okay? It's can you discuss something based on all the information you've picked up, hopefully, by listening to myself and Enda. All right? So that's basically what we're going to cover today. Tomorrow in the lecture, we'll move on to talk about some security stuff and get you back into the groove with security, because when Enda's doing his stuff, he'll talk a lot about stuff that it require you to understand the crypto stuff again. So I'll go through reasonably quickly the crypto stuff. Most of it's the same as what you covered, I think, in second year. So if you understood it and got it down, it shouldn't be too bad. If you didn't, it's your second chance to hopefully to get it into your head. All right. Any questions? No. Let's see. How many did we end up with? 31. Very good. Very good. Okay. I shall leave it at that. I'll kill the video and I'll make it available for you. All right. So I'll talk to you again tomorrow morning early at 9 o'clock. Cheers. Bye bye.